Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so we have question 3, still on intermolecular forces, grade 11. The melting point and boiling point of 4 substances A, B, C, and D are shown in the table below. Then, as we can see the table there, 3.1 says define the term melting point. So to define that, we say melting point 3.1. Melting point is the temperature at which the solid and liquid phases of a substance are at equilibrium. Right. So this is the temperature at which the solid and liquid phases of a substance are at equilibrium. Right. And then for that, you have your 2 marks. Okay, then 3.2 says explain the difference in melting points of HF and HCl by referring to the type of intermolecular forces. Now, because they said referring to the type of intermolecular forces, this throws in a hint that we are now dealing with compounds or molecules with different intermolecular forces. So if we can just check here, we have HF, which at this point we have already identified that if a hydrogen bonds with either an oxygen, a fluorine, or a nitrogen, then the type of intermolecular forces that we have are called the hydrogen bonds. So if you want to remember that, we say HOF-NOF, right? So if a hydrogen reacts with oxygen, fluorine, or nitrogen, we create very strong bonds that are called the hydrogen bonds, right? But then here we have the HCl, and then the HCl, we know it to be a polar molecule. So that means it has what? Dipole forces. So HCl has dipole forces. So at this point, we can say that we are now comparing molecules that have different type of intermolecular forces. Remember, in the previous video, I made you note the ISSE method, which I said this one only applies if we are dealing with molecules that have the same type of intermolecular forces. Now, if we have different type of intermolecular forces, which format should we use now? We should use the ICE format, right? ISE. So this works when we are dealing with what? Molecules with different type of intermolecular forces. Now, what is ICE? ICE means, number one, we have to identify the type of intermolecular forces in both of these molecules, meant to say. Then C means that we now have to compare the strength of those intermolecular forces, right? And then E, this is where now we speak of the energy involved, right? Which is different from this one. Now, you can check out the previous video that I posted for you to understand this format here. But then for you to understand the ICE method, this is what we're going to use to answer 3.2. So, okay, having to apply that, this is how we're going to go about answering this one. So we're going to say HF has hydrogen bonds. And then HCl has dipole forces. So dipole forces. And then this is the part where we now compare. So we will say hydrogen bonds are stronger than the dipole forces. And then this point we have to say more energy is needed to overcome the intermolecular forces in HF than in HCl. So in conclusion, this is why we have HF. That is why HF thus, so let's conclude and say thus, HF has a higher melting point. Has a higher melting point than HCl. So this is how you go about answering that question. So number one, we have identified the type of intermolecular forces. We said HF has hydrogen bonds, it's a mark. We said HCl has dipole forces, it's a mark. We said hydrogen bonds are stronger than the dipole forces, it's a mark. And then we concluded on the energy. More energy is needed to overcome the intermolecular forces in HF than in HCl. So we have touched on the energy, and then this is just the conclusion. Thus, HF has a higher melting point than HCl, which we can all see here. So this one is a higher melting point. Okay, so that's how you go about answering that question for a total of 4 marks. So make sure that you play the video as many times as possible and just try to understand that approach there. Okay, so 3.3 says, which one of the substances, is it A, B, C, or D above, is a liquid at 25 degrees? Now, the way to answer this question is to understand if we are looking for a substance that will be a liquid at 25 degrees Celsius. That means having to look at our boiling points, we want a substance that will have a boiling point greater than 25 degrees. Greater than 25 degrees Celsius. So now, in order for that substance to be a liquid at 25 degrees Celsius, that means it has to have reached its boiling point at a temperature that is greater than 25 degrees Celsius. Right. So that means we can now scale down our investigation only to the boiling point here. So HF, it's reaching its boiling point at 19.54 degrees, meaning by the time the temperature reaches 25 degrees, which is, by the way, this is what we call the room temperature. So sometimes they might say room temperature instead of 25 degrees Celsius. So you have to put it in the back of your mind that room temperature is equivalent to 25 degrees Celsius. So, okay, now let's say they say 19.54 degrees. So at this point already, at the time it reaches 25 degrees, it will already be a gas, because remember, boiling point is when it now changes from a liquid to a gas. So by 25 degrees already it will be a gas. Then this one reaches its boiling point way lower, at a way lower temperature, negative 81.7 degrees. So by the time it reaches 25 degrees Celsius, it would have long evaporated, right? And then what about this one here? Hey, let's start with D. D also, again, same situation as B. It has a lower boiling point. So by the time it's 25 degrees Celsius, it would have long evaporated. But then let's look at C here. There's something special about C. So C reaches its boiling point at 46 degrees Celsius. And having to read this, we said we are looking for a substance that will have a boiling point at a temperature that is greater than 25 degrees. Look at its boiling point. It's reaching the boiling point at 46 degrees Celsius, which obviously this means that the one that will be a liquid at 25 degrees Celsius has to be a compound C or substance C. So to answer 3.3, we simply just say C, right? And then let's now proceed. We have 3.4 says explain why CS2 has a higher boiling point than CO2, right? Now, looking at CS2 and CO2, the one thing that we can identify between these two is that they share the same intermolecular forces, which are the London forces, right? Then this is how we do it. We're going to say both. So 3.4, both CS2 and CO2 have London forces. But then now, what causes this difference if they both have the same type of intermolecular forces? Now, it is the fact that CS2 has a larger molecular size. So CH2 has a larger molecular size than CO2, right? So what format am I now applying? Because I've identified that they both have the same type of intermolecular forces. Therefore, that means I'm now referring to the ISSE method, right? So CS2 has a larger molecular size than CO2. And therefore, this means that we know that the strength of the London forces or the London forces increases with an increase in molecular size. In molecular size. So the bigger the molecular size, the stronger those London forces in that molecule. So the London forces increases with an increase in molecular size. That means more energy is needed to overcome the intermolecular forces. The intermolecular forces in CS2 than in CO2. That's it. So that's how you go about explaining that one. So because we have identified that they have the same type of intermolecular forces, our format now changes to ISSE. So we have London forces, and then we have compared that they have different intermolecular forces, and then also that the molecular forces increases with an increase in molecular size, and therefore more energy is needed to overcome the intermolecular forces in CS2 than in CO2. Right. So that's it. So only 3 marks. Usually it's 4, but then they only gave you 3. Then let's now proceed. We have 3.5 says which one of the substances A, B, C, or D above has the highest vapor pressure? Give a reason for the answer by referring to the data in the table. So we are looking for the one with the higher vapor pressure. Now, we've already discussed this in the previous question that if they ask you about a physical quantity or a physical property, meant to say a physical property that is not here, then you have to relate to it based on the relationships. So when we are speaking about the physical properties, do not be confused, guys. Physical properties are this: your melting point, your boiling point, and your vapor pressure. So how do we answer a question on vapor pressure when we are only given the melting point and the boiling point? You have to realize that melting point is inversely proportional to the vapor pressure, and also the boiling point is inversely proportional to the vapor pressure. So that means if we are looking for the one with the higher vapor pressure, then this translates to the one with the lower boiling point, or higher vapor pressure also translates to the one with the lower melting point, right? So that means here, either we find one with the lower melting point or boiling point, then we are done. So let's check. We can look at the block for the boiling point. We can see that the lowest boiling point here is this one. And even looking at this side here, the one with the lowest melting point, it's still the same HCl, right? So we are supposed to say it's what? Compound B, right? So it's compound B. And then to give a reason for that, it's because it is the one with the lowest melting point. the one with the lowest melting point and boiling point. So there it goes. It's the one with the lowest melting point and boiling point. So that means it is the one with the highest vapor pressure. So that's how you go about answering this question, guys. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.